All right, welcome back everybody. This is section 3.3, find the slope of a line. This is continuing in that same packet that we've been working through. It's going to be a little bit confusing just because this page here is a very good page, but I'm going to actually have us skip it for now and start tomorrow's lesson with it. Okay, so just go ahead and scroll on by to the next page and we'll get started here with some definitions, okay? So the first one that we have is that a rate is just a ratio, which means a fraction, that measures how two quantities change with respect to each other. So you'll hear it a lot in your book as applications, and that's just kind of the fancy word now for story problems. Slope is the same. It's also a ratio, which just means fraction, that measures the rate at which y is changing with respect to x. So this is just in general. So for example, if I were to just look at a graph and try to calculate the slope where it didn't have any meaning behind it, it didn't have a story problem, I would just say something like the slope is 5 or something. But if I'm talking about a rate, I might ask you how fast was the car going, and that would be a ratio of something like 50 miles per hour. So they're the same thing. It's the rate and slope are both the ratio that measure the change with respect to two different things. Okay, so now in number 1 here we have ladder A and ladder B. I have, looks like they're both 12 feet. They're up 12 feet high on the wall, looks like. And then one of them is only out 3 feet, but the other one is out 6 feet. I want you to tell me which of the two ladders shown in the picture is steeper and why. So take a look, think about it. What do you think? Which one's steeper? Looks like ladder B is steeper, right? So it's going to be ladder B. And I'm going to go ahead and write because it takes less distance out to get to that same height. Okay, so I'm going to write steeper. Okay, so one more time, steeper because it takes less distance out to get to that same height. All right, so key ways to think about slope. So I just have m equals slope equals, then I have vertical change over horizontal change. Do you remember which one is vertical when you're talking about x's and y's? The vertical one is the y, okay? So here it's going to be the change in y over, what do you think, the change in x. And another way that we talk about this, you might have heard this before, it's called rise over run. So slope is rise over run. I kind of think of that change in y, since it's the up and down, it's kind of like the sunrise. So that's how I remember rise over run. Okay, so the rise goes first. So let's see what we have next. Find the slope of the line shown at the right. Okay, and then we have this line here. So there's a couple different ways to do this. I think the way that I want to show you is let's try to find exactly on this graph where the line is perfectly going over these crosshairs. Okay, so like for example, it looks like it's perfect here at the origin, here at 2, 1. Okay, I'm just trying to mark the ones where I think it's going straight through. You don't have to mark all of them. You can just pick a couple. Okay. So now I'm going to remember that the slope is rise over run. So rise is how many do I go up from dot to dot? Okay, so here, to get from one point to the next, how many up am I going each time? I'm just going from dot to dot, okay? So just put my pencil here on the origin. I go up 1 is my rise. over is my run, over 1, 2. So my slope is 1/2. Okay? If you wanted to go down, you could do that as well. I think I have more specific notes on this, so I think I'm going to hold off on the next part that I was about to say. Let's instead, let's try to have you do this guy. Okay, so he looks a little bit different. Try to find exactly where it crosses. Gets those crosshairs, and then count rise over run, and tell me what you think that slope is. All right, so I just grabbed 2 of them. If you're still working, just hit pause and come back when you're ready. I just picked 2, so I have rise over run. Now, from one dot to the next, I'm going to put my pencil here. I'm going to go down 1, 2 over 1. But do you notice something different compared to this one? Do you see how from left to right, so if we start here on the left and then read the graph left to right, that this line is going uphill? That is a positive slope. If you look at the graph left to right, so just like how you read a sentence left to right, you read a graph left to right. So if you start on the left and if you dropped a marble on it and it rolls downhill, that's going to be a negative slope. Okay, so one more time, is it from left to right, we have it going uphill, just like how we read a sentence. If we go left to right and we drop a marble on it and it goes downhill, it's a negative slope. So that means that here, where I have the rise over run, it's actually a -2 over 1. And remember, anything over 1 is just going to be itself. So we're just going to go ahead and just write -2 as the slope. All right, awesome. Let's see. Next, we have find the slope of a line that passes through 1, 5 and 4, 3. Okay, now we haven't really talked about a formula yet, but if you're kind of remembering one, you can give it a try. Otherwise, I would recommend just doing just a rough little sketch just on the side. Just see if you can do a rough little sketch. So go ahead and give that a try. I'm going to sketch it out too. All right, so I have plotted both of those points. If you weren't there yet, it's okay. Just hit pause, come back when you're ready. So I just went in and plotted 1, 5 and 4, 3. And now I'm going to look and count my rise over run. So up and down goes first. So I'm going to go down 1, 2, it looks like, and then over it looks like 1, 2, 3. So it's 2 over 3. But if you read it left to right, just like how we read a sentence, you could see that it goes downhill, so it's a -2/3. Okay? Turn the page. And what we have next is it says that the slope of the line containing points x1, y1, x2, y2 is given by m equals slope, which we already said is the change in y over the change in x, which is rise over run. Don't let these little teeny tiny 1s and 2s intimidate you. They aren't like exponents or anything. It's just like, you would say sub. So it's like x sub 1, y sub 1, x sub 2, y sub 2. The reason why they do this is just because when we're plotting the points, it's x's and y's. So this 1 just means that's my first pair, and the 2 just means that's my second pair. Okay, so that's all it is. It's just referring to 2 ordered pairs. It wouldn't make sense just to write x, y, and then x, y again. Because what I want you to do is you're going to do y2 in the formula minus y1 to find that change in y, over the x2 minus x1 to find that run or that change in x. Okay, so using the formula, find the slope of a line that passes through. These points sound familiar, right? 1, 5, and 4, 3. And then I remind you, you just did this in problem at the bottom of that last page. Okay, so then we're going to compare. So we did get negative 2/3. Let's see if we get the same thing. All right, so I'll write this a little bit bigger so it's easier to see. Okay, so I've put x1, y1 above my first set and x2, y2 above my second set. If I wanted to, do you think I could call this set x2, y2 and this set x1, y1? I totally can. Do you think, though, I could start mixing and matching? Like x1, y2, x2, y1? That would not be good. Okay, so do not do that. So just think of one pair gets one number, the second pair gets the second number. Let's erase all that mess. All right, so let's go and plug it in. I'm going to rewrite the formula again. y2 minus y1 over x2 minus x1 equals, so I said my y2, I want it to be 3. So I have 3 minus 5 over 4 minus 1. 3 minus 5 is a negative 2 over 4 minus 1 is 3. So the slope is negative 2/3, and that is what we got on the other page. You know what? I usually end up doing this in class, so I'm going to go ahead and do it now. Off to the side, you don't have to write this, but a lot of times I have students that they don't quite believe, which is good. I like it. I like it when they question it. They don't quite believe that we would get the same answer if we called this x2, y2 and this x1, y1. So I just go ahead and do it real quick. Okay, so let's do it and see if we do get the same. So I'm rewriting the formula. Now I said that my y2 is 5 minus my y1 is 3. x2 now I said is 1 minus 4. 5 minus 3 is 2 over 1 minus 4 is negative 3. And that negative, I don't know if you know this, but that negative, he can be up top, he can be on the bottom, he can be up front. Every single one of those is equivalent. They're exactly the same. Okay, so we did get the same answer. Very cool. Moving along, I think I'm ready for you to go ahead and try both 6 and 7. Okay, so it might take you a little while, and don't forget that when you subtract a negative, you change it to addition. Okay, so that's your hint. So go ahead and hit pause and come back when you're ready to check. All right, so we have y2 minus y1. I went ahead and labeled them. And x2 minus x1. So for the y2, I have 2 minus the negative 1 over x2, I said was 4 minus a negative 5. Now, subtracting a negative is the same thing as adding. So really what I have is 2 plus 1 over 4 plus 5 is, oh, actually, I'll just write 4 plus 5. We can do this in a couple steps. So 2 and 1, I get 3 over 9. Am I done? I can reduce it. Reduce it down to 1/3. There we go. Perfect. If you didn't get that one, or actually, no, I'll just tell you this instead. How about number 7 ends up being negative 1/2. So if you did not get negative 1/2, take just a minute, hit pause, and give it another try. Otherwise, I'm going to keep working through it. So I have negative 5 minus a negative 3 over negative 2 minus a negative 6, negative 5 plus 3 over negative 2 plus 6 is negative 2 over 4, which is negative 1/2. All right, very good. Number 8. Number 8 says to find the slope of a line passing through 5, negative 4, and 5, 3. So go ahead and plot those points. Then draw a graph of the line using these 2 points. Actually what I want you to do is do the y2 minus y1 and then go ahead and plot them, okay? And then compare. Something weird's going to happen. I did that on purpose, okay? And then try, there should be another one on this page. Yep, there it is. Try that one as well. So try both 8 and 9 by using the slope formula that we just learned, and then go ahead and plot those points and connect up the line to see what's happening. And there's 2 weird things that are happening. Okay, so hit pause, come back when you're ready. All right, so I have 3 minus a negative 4 over 5 minus 5. This is already a little bit strange, right? Because I have 3 plus 4 over 5 minus 5. That's 0. I thought we couldn't have 0 on the bottom. Okay, so I have 7 over 0. Well, let's see what that looks like if we go and plot it. So if I go to 5 and negative 4, that's here. If I go to 5 and 3, that's here. Well, my rise over run, it is up 7 over 0. What's happening here is we have a vertical line. And that vertical line means that this slope is undefined. And we've been talking about this already this quarter, right? That if you have 0 on the bottom, that it's undefined. That if you type in 7 divided by 0 on your calculator, it will either say undefined or error. Okay, so the same thing is happening here with slope. If we divide by 0, we call that undefined, and it ends up being a vertical line. Let me connect the dots real quick. And then we'll look at the next one. A lot of people want to say that this slope is 0, but it's really not. Okay, it is undefined. So in the next one, also a little bit weird. So for this one, find the slope of a line passing through 4, negative 2, and 0, negative 2. Okay, and something weird's going to happen here too. So we did negative 2 minus a negative 2 all over 0 minus 4. So negative 2 plus 2. Let's see, over that negative 4. Now, negative 2 plus 2 is 0 over negative 4. But what is 0 divided by anything? It's just going to be 0, right? So this means that our slope is 0. And what happens when we plot them? Let's see, I'll go to 4, negative 2. And I'll go to 0, negative 2. And let's going to connect those guys up. All right, and look at that. There's our slope is 0, and it ended up being a horizontal line. The way I try to tell students how to remember what's 0 versus undefined is that we talk about slopes a lot, like with skiing, like you ski down a ski slope, right? So if you were to come across, if this line here that's on the screen represented a ski slope, there would be no slope, right? And it would be like cross-country skiing. It would just be a slope of 0. However, if you are skiing and you come across a sign like this, that would probably not be a great idea. I would not ski down that for sure, okay? Hopefully that helps. So slope of 0, vertical is undefined. Oh, hey, we're almost done, I think. I think this is the last page already. I just want you to give it a try. I think you can do this, yeah. Yeah, go ahead and try it. So hit pause, come back when you're ready. Okay, so it says, which of the lines at the right match the description? So positive slope. Do you see anybody that's positive in there? A for sure. There's one more. Did you see it? It's not as prominent. But C, even though that's super, super slightly positive, it technically is still positive. Slope of 0, I don't see any of those. Negative slope, how about B? Undefined, that's definitely D. And then it says one of these does not have a match. For that description, draw a line on the coordinate system that would meet that description. So it looks like they're wanting us to go fill in a slope of 0. So I'm just going to write none. and let's go make one somewhere. I'm gonna grab my ruler, and just anywhere you want. Just put in one with a slope of 0. Hey, you can even see my rulers even telling you it's 0. Cool. So I just put him in there, and I'll go ahead and write line E, just so it matches. And that should do it. There we go. Awesome. I hope you have an amazing day. Good job.